All right, class, today we're going to look at how the universe formed. You're going to be taking notes in your cosmology packet here, starting with the ones that say, poof, a universe is born. And we're going to burn through some serious pages of notes here, so get ready, saddle up. If I go too fast, if I go over something too quickly, or you miss something, please feel free to pause, go back, read through the notes, listen to what I'm saying, and look for the information so you can fill in the blanks on the paper. We want to know how our universe got here. It's kind of a big question. And the explanation for how our universe got here is called the Big Bang. And so we're going to go through on your sheet here, kind of the who, what, when, where of that. And we're going to start with the what, or excuse me, this is a basic term here. Okay, so what exactly are we going through? We're going through a sequence of events. A happened, B happened, C happened. That's how we're going to talk about how our universe formed, okay? And the first part is the what. So what exactly is the Big Bang? It's a very misleading name because it makes you think of an explosion, but it's actually an expansion that happened 13.8 billion years ago. We can figure that out by calculating the rate at which the universe is currently expanding to find out how long ago the expansion started. Okay, so you have the topic, you have the what, you have the framework, and you have the when now on your paper. So where? Well, the universe started from a singularity, and a singularity is a very, very, very tiny point. In this case, it was about the size of an atomic nuclei. And this blows people's minds to think about it, but essentially our universe used to be the size of an atomic nuclei. Nothing outside of it, because the universe is everything. So it used to be really, 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 really small. And then what happened was when the expansion occurred, it created space, time, matter, and energy. Okay. Hopefully you can figure out what symbols on your worksheet coordinate with each one of those words and put them into the correct boxes. But this is the who, what, when, and the where, and the why of how our universe formed. Now we're going to get into some specifics. So what was our early universe like? It was really tiny. Okay. Because it's so tiny, everything's really close together, and it is redonkulously hot. Okay. It's very dense. And it's compacted into an area now the size of an orange. So it's expanded much, much larger, but still pretty tiny. Everything's moving really fast because they're always bumping into each other, and they're very hot, and there's no light. So it's completely dark, and we don't really have any elements either. So it's a crazy time in our early universe. Hot, dark, dense. It's not what you would expect today, not what you're thinking of. Okay, so after the Big Bang, so this is when things start to cool down. We finally get the release of the first light, which is the cosmic microwave background radiation. Boom, now we have light. And it is still visible today, that cosmic microwave background radiation. And then the plasma cooled to where the electrons quit flying around and smashing up, and all we had was nucleus and electrons. Now they've settled down, and we've been able to form two elements, the simplest elements, the smallest elements, hydrogen and helium. All right, so let's talk about energy forming in our universe. So before the Big Bang, energy, light, matter, time didn't exist. It was all confuzzled all together. And then when the expansion happened, these things started to separate out in a very, very short period of time. Energy and matter separated from each other. So what happens when energy separates? Energy, if we're now on this page here, in your notes, where it says energy at the top. So our concept is that energy is the ability to cause change, okay? And so our framework is we're using natural laws that deal with energy and sequence of events. We're still going through the steps in the formation of our universe, okay? At the start of the Big Bang, energy and matter were the same thing, and then they separated a very short period of time after that. And once they separated, then we get matter and energy as two different things. Although Einstein's equation E equals mc squared, which is on here on your paper, make sure you fill in these letters right here, okay, tells us that energy and matter are actually equal to each other, which is kind of, again, wild to think about that. So what happens then? The first thing that happens with energy is that it splits further into what we call the four fundamental forces, okay? And now we're going to fill out the table on the bottom of your paper, okay? These are push and pull forces. So here's your table, okay? So the first force to separate out is gravity, okay? That is a pulling force. It happens between all matter. It's the weakest, but it has an infinite range, okay? And then the strong nuclear force is what holds together the nucleus of an atom. It is a pull force, and it is the strongest, but it happens over a tiny distance because we're talking about in the nucleus of an atom, right? And then the electromagnetic force, this is what you're thinking of when you think of like magnets, okay? And it's a push or a pull because obviously the same charges repel each other and opposites attract. And it also has a huge distance it can work over, and it's strong. But the weak nuclear force is what causes atoms to decay apart. It's a push force, not very strong, and happens over a very small distance because, again, we're talking about atoms. So again, if you have to pause this to get this filled in on the table on the bottom of your paper, please feel free to do that. Okay, so we've talked about energy now. Now it is time to talk about matter, the stuff that is important to you and I, that makes us up, that makes your cat up. Okay, so how did it get here? Well, matter is anything that has mass and volume, okay? And our framework for this, again, is a cause and effect. So something happens, and this is the result of that. And then again, we're still going through that sequence of events. So what happened first with matter in the formation of our universe? What happened second? What happened third? Et cetera, okay? So initially what happened was, all we had was electrons and quarks. These are the smallest objects in our solar system, or excuse me, of material, okay? And they're filled out here. Electrons have a negative charge. Quarks can be up or down. You can see that from the symbols. We have up quarks and down quarks, and there's other ones too, but I'm not going to get into those. Okay, so then the strong nuclear force bonds them together. We get protons over here, which have a positive charge, and neutrons, which have no charge. And then the universe had to cool down because we couldn't form anything other than nuclei and electrons, and they're all swarming around like a bunch of angry bees in this plasma, okay? But then eventually, over time, it cools down. And when it cools down enough, then the electrons can bond to the nuclei, and we can start forming atoms, okay? And the most simple atoms on the periodic table in the universe are two, which you are familiar with, and or you should be at this point. And those are hydrogen and helium, okay? And you'll want to label those down here. This guy is hydrogen. This one is helium. And then you're going to fill out this diagram from the next slide. Basic stuff about the layout of an atom, okay? Here we go. You've got two assignments you're going to do today. First thing, you're going to do this roadmap. So you're going to use the notes you just took. If you don't have the notes, this is going to be super hard. So you're going to fill out this based on your notes. The symbols on here might help you to figure out where to put different words. And then when you're done with that, you're going to do this. And we're going to talk about some of the specific things that went on in the Big Bang. We're going to talk about the timeline, the order of events that happened, and then answer a few more questions from your notes on the back. So you got a couple of papers you're going to work through. Good luck.